We are going to have a first assignment. Here will be here around 11:10. So what is the assignment? Site. This is our FTP site. Download and homework. So we can provide you some data. Will include some data. Visible and download PPT and data set. So third hour. That is the homework. So this right now is a week 5. So there is a course I will teach you. Hopefully a little bit this empty. I will try to finish stereo. Finish your stereo. Our first main part is the sensor. So sensor we talk about visually is talk about the camera things. So this one camera and when I'm talking about more than one camera is 2 cameras. The stereo is for the 3D. And later we talk about SIFT. Sure. Stereo. So what will I teach you for the stereo? Stereo will consist of the intrinsic players. We want to design stereo system. Purpose is try to find the 3D scenes of try to understand the depth information. Or you need to do calibration in basics. Lens distortion. I will include one more term is that we call rectification. And in Mandarin, we talk about calibration is 校正, and rectification also is 校正. Both are 校正, but in English, the difference. So we talk about calibration include the 3 parts, and the rectification is between, if you try to calibrate between 2 cameras or 3 cameras, more than 2 cameras. So that's called rectification. I'll teach you. And when we do that, try to find a match. We will talk about a similarity. And we try to talk about and mention about a match. Usually it's a 2D search. But for stereo, you need to search it pixel by pixel. So that takes time. We need to reduce the 2D search to become a 1D search based on the epipolar. We'll talk about epipolar. When we talk about epipolar, we need to talk about essential matrix and the fundamental matrix. And both matrices are the basis matrix to understand the stereo. And inside the stereo, we try to find corresponding point. So that's corresponding point. So that's the matching. Matching is kind of a similarity measure. What's the similarity measure? So in this lecture, I always keep talking about detection, tracking, recognition. And the detection, tracking, recognition, all are matching, all are similarity measure. And the basic similarity measure is the exponential term of Gaussian model. I keep mentioning about that one. So exponential term of Gaussian model, that's a similarity measure. And also it's kind of a maximal likelihood. So you have a maximal likelihood, you need to times prior probability. And that's will correspond to the posterior probability. So that's a Bayes theory. Bayes theory I will mention about that's the basic theory in AI. Okay, so next stage I'll talk a little bit about the Bayes theory. So back to the similarity measure. So you try to find corresponding point, and the three parts are important. Is what's the window size? What's the search range? How do you measure? Matrix is meaning how do you measure the similarity? Like a SAD, mean square difference, sum square difference. Those are the or Euclidean distance. Those are matrix. 是有衡量的一种单位哈，衡量的机制，这是一个概念而已。And with the depth segmentation, second is meaning we try to separate foreground to the background, or separate two objects pixel by pixel. We call segmentation, and there's several methods. So for the stereo, it's almost the same. So the important part is the first one is this one. How can we reduce 2D to 1D? The second part is the measure, the similarity measure. So we'll start to talk about stereo. And you can check those things by yourself. Here is let me check. Try to find the depth information. 深度哈，你要找深度嘛，就 depth information. There are several methods. Okay, so declaration, shading, texture. You don't need to remember this one, just because some methods not so good. Focus 就是那个前景聚焦后背景聚焦。So you can based on those information, combine both information, you can have a 3D information. It's motion. Many other methods. And those methods we call shape from something, shape from shading, shape from texture, shape from motion. So what's a shape mean? Here, shape meaning 3D object. So when you see some paper talk about shape from something, that's meaning this is a 3D reconstruction. So we try to simulate our eyes. So that's a stereo. Our eyes, both eyes is two cameras. Okay, so that's a stereo. We start from here. So suppose we have a left camera, right camera, two camera. We have two camera, left and right. And we take the photo, take the image. So it's left, right. If we try to align to this way, you'll find if the object is near you, this object target near you, so the nose is here and nose is here. If I move this point to here, you'll find the distance between 2 points. If I move this point to here, you'll find the distance between 2 points is wider than the other one. This further than you, 比较远的物体. If I move this one to here, you'll find the distance between 2 points is short. So that's meaning if an object close to you, the corresponding point, they have a long distance or wider corresponding point for an object near you. The object far away from you, their corresponding point will be shorter. So based on the distance between two corresponding points, you can find the depth of object in front of you, and between you and between the camera and the object. Okay, so the distance between two corresponding points we call disparity. So for stereo, the purpose for stereo is try to find the depth, the distance between the object and the camera. But in order to find the distance, you need to find the disparity. So disparity is based on the two images, the distance, the corresponding point distance, or distance between two corresponding points. So the object close to you, they have a longer distance. The object far away from you, they have shorter distance. But in the infinity, the disparity is zero. 无穷远的地方，它的 disparity 是0.0个 pixel 这样子，就无穷远的地方。So here, the important one is how can we find the corresponding point? How can we find a corresponding point? That's the purpose. So this one is the example. Two objects separate. So if a object closer to you, we use a more bright color. The object far away from you, we use a dark color. But you'll find there are some holes here. So when you, even though right now, if you do stereo, there are some holes. What mean holes? Holes meaning they cannot find a corresponding point. Even though right now, still have some points you cannot find corresponding point. Why? Because there's no texture. No texture, if there's no texture, you cannot find corresponding point. So what's the good feature? The important. Good, we say, good feature. The good feature, how do you judge is a good feature? And we'll teach you about next SIFT. So on the next lecture about SIFT, I will teach you what's the good feature. Good feature is meaning there's more texture. 就比较多纹路，比较好的 feature. So when you do the deep learning, they do the encoder, they do use the filter to convolution to extract the feature. Extract what kind of feature? Extract good feature. Sometimes if it's a textureless without any too much textures, it's not easy to extract the texture. Texture is very important. So this the other example is suppose this camera center. And you try to find object at one point here. So this 3D point, if you project to 2D and they will intersect this point, how can you find the corresponding point from left to right or from right to left? That's what we try to teach you. So first of all, teach you after three methods, we talk about the Z, the estimate. Z is the distance between the object to the camera. It's at any point in the 3D, there's any point. How can you measure, you have X, Y. How can you measure the Z? How can you get the X, Y? Actually, we already did that in camera calibration. You will see the point X, Y, and after rotation, translation, and then use the intrinsic parameters project to the image plane in the 2D UV or XY. So this point corresponding to the 3D points, the XY axis, XY component or element is based on the intrinsic parameters. The more important thing is intrinsic parameters. But for the z, there's no z information here. How can we find a z? We need to use this equation. So for the z, we'll see methods, but here I just suggest you to another. I give you more information, different information, but I just teach you the second method. And for you, just try to understand the second method, because second method is easy to understand and more straightforward. Okay. So how can we measure the z? And we should define. So suppose this 3D points here, and this camera center, and this camera center. So we have camera center 1, camera center 2, because we have two cameras. Two cameras, and then the distance between two cameras we call baseline. 基准线 基准线 baseline we call B, defines B. So the distance, and this B is you design. Stereos is you design. So if I design two cameras and put two positions, my experience is this one is between 5 centimeter to 30 centimeter. And when I was in USA, in the work with the Army, the DARPA project, I tried to measure the distance far away from me, about 100 millimeter. This distance I just use 15 centimeter， 就是这个距离通常5公分到15公分就可以看得远。So we'll think of how about satellites. Satellites in maybe 100 kilometers above us, and how can you measure the ground? So what's the baseline here? The United States satellites, they have a stereo system out of us. So how can they measure this one? So what's the distance between this one? 你要看几百公里，要看几百公里外的物体，那你 baseline 要调多远？实际上我不知道这个机密，我看过那个影像，真的是看到是3D的。有一个方法嘛，就两颗 satellite 各有一颗那个摄影机，那2个距离就可以量地上距离嘛。是我不晓得他们真的会这样做吗？那第2个方法就是一颗那个卫星上面有 stereo system， 可是他要看几百公里的地上啊，他怎么看？这 baseline 怎么设计，我真的不知道，还是他们的国防技术。我去他们军中也看到3D 的那个地上的状况。好。back to here， 多军事机密上，我有时候看了不知道怎么去聊，不知道怎么破解它。So we have baseline. And F is the focal length. So F you design F because you select the camera. So you given the B you know you design. F you need to select. So this focal length. So this image and this image. And usually when you design the stereo with 2 camera, you will use the same brand of camera. 尽量用相同的摄影机品牌，不然你迟早麻烦。通常是把就是相同摄影机的 f 然后相同的镜头嘛，是吧？ So f will be the similar, almost the same. You design B, you design F. So what we'll try to measure is distance disparity D. So after you measure disparity D, you get it, the Z, distance Z. So First, the next step is for this two camera system. We assume the first camera system, 3D system, we call the reference coordinate, REFERENCE. No matter how many cameras you design, you should only pick up one reference camera, 以我为基准。对 ，so this we assume the camera one is a we call reference 参考坐标参考摄影机 reference。So then you don't need to worry about how many cameras of you. So we call this one. Right here. The unit is also important. Usually the Z is meter. The unit is meter. Baseline is the centimeter. For the baseline, my experience about sometimes see if you use a RealSense can probably the stereo. RealSense use stereo. RealSense. And show some RealSense information. RealSense is a stereo, and I think there's only 3 centimeters away. So there's about 3 or 5 up to 30 is my experience. And this focal length. Focal length unit is millimeter. So the important one is the disparity, pixel. Pixel sometimes is mm. Pixel 之间的距离。Here, how can we get this result? So almost all 3D things, they all use the triangulation. 任何3D 的3D 坐标东西，几乎都三角，像是三角量测方式来做，几乎都是这样子，不难。So stereo theory is not difficult. Why stereo is complicated? Because you have a 1, 2, 3, 4. You have four variables. 你有4个变数，因相互影响。4 variables, variability 有4个变数，上次这4个都是变数。都要去设计，难是难在这里，所以是 stereo 难不在理论，是难在实际上在做的时候。Back to here. So in order to get this result, what's this one? This one is here. So Z, this one. If Z compare with the baseline, this triangle. If Z compares baseline to this, sorry, this triangle. So if it's this one. If this one, if Z is D, here is this Z minus F with this one.太难了，这没有，氧气会不会太难？我这边没有，遥控器不在我这里。是。This triangle. So this Z is this one. Compare with this one. Because this F, this distance compare with this one equal to this one. Compare with this one. I say again, this z compared with this distance equal to the spaceline compared with this one. From the this triangle compared with this big one. This part, this height compared with the entire one equal to the baseline. So that's here. So this is a longer distance z. This baseline z with the baseline, the ratio equal to the small one, this small one. Z compared with, so this z compared with this baseline equal to this short one, z minus f compared with this one. So what is the distance between both? The distance between both is the entire this baseline minus this distance, and also minus this distance is equal to this distance. So assume this is a reference coordinate. So this x, this is z. So this side, this one is a positive. 坐标是正的。For the coordinate, c coming down to this one. U2 is a negative. What you do is there's 1 minus U2. U2 is smaller than 0, so that's meaning U1 minus U2. So this will be distance between two. But why they want to say this one? Because if there's a vector, but you do this one, so that's we call disparity here. This part is disparity. What's a disparity? Disparity is here. This point here. Disparity distance between two corresponding points. That's called disparity. Disparity means if this point here, the distance between two corresponding points is disparity, because we call this distance. So distance is here. That's between 2 points. It's called disparity. So the equation is this one. 两个相似三角形的比例这样子。Solve this one. So this is z is 1, this 1. So this finally will be this minus, so we don't care about minus. So f compared with z, f compared with z equal to this disparity. B compared with B. Second, this one, F compared with D, this part. F compared with B equal to this is D. This one is B. Disparity. B compared with B. So B, if we move B to here, B compared with B equal to F compared with C. So we design, we know B, we know F. So if we know the disparity, we compute or calculate the disparity D, we will get a Z. So that's a stereo. So stereo is, I say again, we want to measure the distance. How far away from you, this one? How many meters away from you, the Z? So we compare Z based on this equation. This equation is from here. The similarity between two What's the meaning here? So this is baseline. Baseline. So you know the baseline, you know the four coordinates, and this is corresponding point. Each point is corresponding point. So you need to measure disparity in order to get final result of C。那这不用背它，不用背它，简单讲就是说，你把那个 F 啊，你把这个 F 拿过来这里，我把这个拿过来这 F，不要那个 F，你把 B 拿过来这里 B。Then you'll find that if B will move here, so B is here. This B compares Z. And move B. Baseline B compares the Z equal to, so Z is the distance. So this distance means the focal length. So it's focal length F. There is a distance between B。再讲一遍，这个不用背，最后结果就是你把 B 移过来，意思是说我的基本的 B 嘛 ，B 就被两个世界距离。The B equal to the distance between two camera. B here. So B compares D. D is what? The distance between two pixels. So in reality, the B move me to here in denominator term. B is the distance between two connected. Disparity is a distance between two points, corresponding points. And what's F? I'm sorry, what's the denominator term? The distance Z. Is F. F is four coordinates. 这个不要背，不用背它。最重要的是两颗圣殿距离跟焦距离。记得我一直讲 ，for the intrinsic parameters, the most important intrinsic parameters is F for coordinates. Why? Because we need F here. So F is the most important component for 3D. So F is here. So if you know the F, so you can measure the Z. So this is the stereo. We go to the page. Page 14. Page 14. So right now, for the stereo equation, we know B. We use the intrinsic parameters F by camera calibration. Or when you buy the camera, they will give you the four coordinates F. But important thing is that for the high precision measurement, even though the camera company give you lens, so the lens they have four coordinates, give you the four coordinates, but you still need to do the calibration. 你要做高精密度的那个量测 F， 你都要重新那个校正一次，不然就得去用那个板子去校正它一次，不校正去得到那个 F 的资讯标准。So right now, how can we find the corresponding point? How can you find corresponding point? So I want to introduce here this one. We need to understand the epipolar geometrics. Epipolar, they have a called epipolar constraint. What's epipolar constraint? Epipolar constraint is meaning we want to reduce the 2D search. This meaning what? It's meaning for this point we come here. And you try to find from this point, how can you find the corresponding point here? Basically, what you do is you need to have a search range. This search range region, and you've got a page here. So the page you will search from this one, pixel by pixel search. Suppose the search window is 3 by 3. Suppose search window size is 3 by 3. Why 3 by 3? Why you didn't in the convolution field is a 3 by 3? It's because that is to save the time. 3 by 3 is not a good window size. But if you use a 5 by 5, 7 by 7, take time, 花太多时间。3 by 3 is not a good window size or good filter size. But why we still use that one? Because it's just trying to save the time. So if 3 by 3 window here, you search into search, and you use the SAT, use the NCC, normalized cross correlation, or SAT, and you pick out the maximum value here. And that's your corresponding point. But for the stereo, each pixel, you need to do this kind of search process. So that's the waste time. How can you do the real time? The important thing for stereo is that you need to do the real time, otherwise it's useless. 你要做 stereo， 记得 stereo 的目的一定要做 real time. So if the robot has 2 eyes and then camera, right? So what's the real time? Real time is meaning every second you need to process 30 frames, so 30 frames per second. 你1秒钟要处理30张，那每一张你的解析度。以前解析度是我那时候只有64乘480嘛，20年前。那现在就是 2K， 所以你看到 2K、4K 要做 stereo 就头大了，要做那么多点，那你还有一个 streaming， 要处理那么多资料，你会做不完，电脑没办法处理。So no matter is the auto driver car 就是那个 ADAS 自驾车 or the robot， 自驾车可能有超过10颗摄影机，那其中有几颗摄影机是 stereo， 那么它处理数标这么快怎么办？这是一个很头大的问题，所以不要小看这些东西，它总不能放一台 PC 在上面，一道好点，要用板子。那叫用嵌入式板，对 ，NVIDIA 就是卖这个嵌入式板。那是我跟德州仪器合作，它一块嵌入式板20万台币啊，可以8颗摄影机进，就帮他做一点东西，然后最后他被 NVIDIA 打败了，所以他退。美国公司这样子，就是公司有时候他发现这市场不行，他就整个就退出，所以那很残忍。跟他合作5年嘛，合作都摄影机。其中最后1年在做车子，因为已经做到我们刚做的以前做surveillance，我做surveillance也做了将近20年，就监控，那全台湾我最早做，我1993年就在 CMU 在做，然后去美国国防部也做surveillance，然后大概我最早做，把 face recognition， 然后我们最后跟 TI 做那个自驾车这一块，就 ADAS 这个，我们做很多。他们已经做很久，然后那个时候我记10年前，然后他没出版子，然后给我们，然后没做，然后他最后发现他控不过，那我当然不知道这个消息，之后他们就把这个 project 停掉，所以那时候在2010年左右，我印象中我记得就把他先裁掉一个部门，全世界裁掉一个部门，就 OMAC 那个裁掉，就裁掉手机部门。TI 手机部门输谁忘记了，全部裁掉，全世界全部裁掉。那第2个部门裁掉，我讲部门不是小部，一裁就是几千人这样子，包括台湾整个都裁掉。那第2个部门就是退出车用市场。所以那时候我们就做了1年， 然后他就说这挺惨的，这绘本是不错的，因为书不一定啊这样。我们跟他合作也很愉快，因为美国公司比较 open，他们会有一些 source code 什么资料都会给我们，我那边常常会看到。那我现在又有 Intel 的资讯，适当的给你们看。但是呢，不要说跟我合作都失败啊。Intel 要攻 GPU 这一块市场，上次我跟你提到啊。那我这边会有，待会我们下课找一下那个 RealSense 里面，包括我自己听到消息，RealSense 要停产，然后有另外一家公司跟我讲要停产。最近 Intel 给我的资讯是有下一代的 RealSense 这样子，所以到我也搞不清楚有没有停产。官方说停，如果说停产，是 Intel 给我是又有下一代的 RealSense 出来的，那我再给你同样一些。好，那回到这一边哈。So this is for the matching, right? No matter you use SAD or NCC, this research. So how can we reduce the 2D search? Just use this along this line, along this line. And you can use just 1D search to reduce the search time. So that's the epipolar. So the purpose for epipolar constraints is try to reduce the 2D search, 1D search. So what's the epipolar line? Sorry, epipolar constraint is this one. We define first, 定义一下。First of all, there's two commands. There's left command, there's right command, right? So this line is baseline. This baseline. So in 3D, this is a camera center. So if a camera center, this one. So from C right, camera right, you see this center. 你看到这颗摄影机，有这颗摄影机的 center, this one, project to this camera and this point, image point, we call epipole. 就两个摄影机，假如两个摄影机没有不是平行的，那从这一个摄影机就有这一个右边摄影机有左边摄影机，看到左边这摄影机的假设中心点，这个就是这一点就 epipole。In the other way is the camera the camera 3D coordinate the center here project to the other camera. This is the epipole. So we have two epipole. The important thing is the epipolar line. What's epipolar line? So for any image that exists only one epipole from the other camera. 是每一个影像只有一点，就是对这两个摄影机来讲的话，左边摄影机它看到右边摄影机，它只有一点 epipole，只有一点，唯一一点。右边摄影机看左边的话，因为只有一颗摄影机，所以只有一点。那 epipole 很重要，可以找得到。待会继续讲。So any 3D points project on the camera coordinate. So project on the image, and there's one point. So this projection point 是刚刚那一点。So a line passes through this point, epipole, we call epipolar line. So this is your search line from 2D reduced to 1D. So any point in the image, there's a corresponding point here. Corresponding point, this line is called epipolar line. So your corresponding point will exist to one point. So in the left side, there is epipolar line. There will corresponding epipolar line on the right hand side, right command. I say again, any 3D point, right, you project on the left side, there will one, the image point they call. And this point, if you connect to the epipole, and this line called epipolar line. In left side epipolar line, there will has a corresponding epipolar line in the right side. And the corresponding point on the right hand side, this point unknown, you will appear or you will exist the right hand side epipolar line. epipolar line 是对称的，那任何一点，你在左边看到的任何一点，这个连出来 epipolar line 是可以找到右边的 epipolar line，然后你对应的点一定会出现在这条 epipolar 上，所以你的2D 摄取就变成 1D 摄取，你只要沿着这个 epipolar line，就是这一点你有个小 window，你只要沿着右边这个 epipolar line，你一定会找到对应的这一点位置。所以 2D search become 1D search. It's called epipolar line. OpenCV give you the method try to find epipolar. So this meaning, no matter the two cameras, no matter how you put the camera between the two cameras, you always can find epipolar line. Based on epipolar line, you can find corresponding point. So become 3D reconstruction. 你看那个电视有没有那个棒球？你看到是我老板放的，他贴我老板放。你看棒球有时候有那个镜，我到这里给你看静止动作，挥棒有时候静止下来，然后摄影机从第一颗摄影机到10颗摄影机跑到第10颗摄影机，然后再继续播放不同角度播放。这个就是要把 epipolar line 就变成一条 epipolar 找到，就可以找到对应的。所以这里可以假设这里有5颗摄影机在这边，就一条线的，那你就每个 epipolar line 就知道了，这样事先把它校正，这个变重复，这个播放那个从这个角度看，那个角度看，所以待会下课我再找一下给你看。OK， 所以是 multiple cameras。This one, what I try to say is that this one. So any point, for this one, any point, you can find an epipolar. After you find epipole on one point epipole, so you can find an epipolar line in the other camera. So corresponding point, the same point 3D project to 2D camera, project to 2D image. So you can find this corresponding point. It must appear along this corresponding epipolar line. 这两条 epipolar line. So this plane is an epipolar plane. So epipolar plane will intersect the two epipolar lines. So this is one example is that, so PA is 1 point. So this 1 point has one epipolar plane. The second point is second epipolar. So later, next one I will explain to you. First of all, the camera position. There are 3 kinds of camera position. We call camera pair. Camera pair 一个2个摄影机之间上只有3种摆放方式这样子。We will continue to cover this one. And go to the FTP site to download the homework. In the third hour, we'll talk about it. 那你有任何问题，现在可以问。